Welcome to KHS Science Videos. This is an investigation into the effect of antibiotics on the growth of bacteria. Whenever we're working with bacteria or any other microorganisms, we have to carry out everything under what we call aseptic conditions. That means we're reducing the risk of contamination by anything other than that which we want to grow in our petri dishes to an absolute minimum. So in the preparation, I disinfected my work surfaces and I sterilised all my instruments in the autoclave before use. The bacteria that we're using for this investigation is called E-coli K12. You may have heard of E. coli and heard that it can cause some very nasty sickness in humans, and that may alarm you to think that we're using that in school. Well, let me reassure you, there are many different strains of E. coli and this strain is not harmful to humans. The antibiotics we're using are penicillin and streptomycin. So the first thing I had to do was I had to inoculate some agar with the E. coli and put that into a petri dish. Then I put a paper disc containing the antibiotic in the middle of the petri dish. I seal up the petri dish in a very special way. We only partially seal it. I'll bring this closer so you can see. We just put 3 small pieces of tape around the dish like that to keep the lid onto the rest of it. We have to be very careful not to seal it all the way around. If we were to do that, we'd cut off the oxygen supply to the petri dish and we would run the risk of growing anaerobic bacteria, and they can be harmful to human health. We also have to write on the disc, on the dish, the date, what we have growing in our dish, and our initials, so that everybody knows exactly what's in there. Then we leave it to incubate for a couple of days in a warm place, but not in a temperature exceeding 25 degrees Celsius when we're in a school setting. That's because if temperatures were to get close to that which we find in the human body, we could end up growing bacteria that could be harmful to our health, so we want to avoid that. So I'll show you the results. This is what happened after a couple of days. It's not going to be very easy for you to see on the video, but the bacteria can be seen in the fuzzy pattern that covers most of the agar. I've drawn a ring around a clear zone that surrounds the antibiotic disc. That is called a zone of inhibition, and that is where the antibiotic has inhibited the growth of the E. coli. So that shows that streptomycin is effective against the E. coli. The zone of inhibition is a little bit easier to see on this printout here. Can you see that clear zone around the discs? And you can see that one disc has not got a clear zone around it, no zone of inhibition. So that means that the bacteria is resistant to that type of antibiotic. Now that is what happened with our penicillin. No clear zone of inhibition. So the E. coli is resistant to penicillin. So why is that important? Well, if you go to the doctor with a sore throat, they might decide that you need some antibiotics to make you feel better. And the doctor needs to know which type of antibiotic to prescribe you. If they were to prescribe the penicillin, you'd take that for a week and your sore throat would still be bad. It would have no effect because it's the bacteria causing your sore throat is resistant to penicillin. But your doctor would know that. They've spent many years in medical school and they'd give you a more appropriate antibiotic, possibly streptomycin. And you may also have heard on the news the dangers of overusing antibiotics. If we use them too often or in the wrong way, the bacteria can become resistant to them because they mutate, and that gives them an advantage, and so they proliferate and the colonies become resistant to the antibiotics, and we no longer have any medicines to clear up our infections. So that is why there are researchers all over the world in labs working to discover new antibiotics to help us in our fight against disease. Maybe that's something you'd like to do.